but that's not the complete solution. The complete solution should include password management as well. We should make sure that the weak password can't be reset. We need to find out where it's hard-coded. We need to also think about password management for not just the password complexity, but making sure that account's locked if somebody tries to break in. That leads us into audit. We have to think about finding out who's trying to connect us this account, and so on. So solutions for Oracle databases are often complex because we need to think about this layered approach. So we need to have multiple things that we're doing. And really the first point was highlighting, don't just follow the list.
Pete, pardon me, we have a question in the queue I'd like to put forth. On the previous slide you mentioned CIS and the CIS checklist. And a question in the queue is, what is the CIS checklist?
Yes, I actually spelled that out on a previous slide here. Center for Internet Security. So that's a website. If you search in Google for Center for Internet Security, or you can go to my website and go to the white papers page, and if you scroll down the white papers page, there's a section on checklists. You'll find a link to it. It's an organization in the States that have created checklists for lots of different platforms. So Oracle, obviously, SQL Server, Windows, Unix, and so on. They've created checklists, lists of things you should do to harden the security. So it stands for Center for Internet Security. Have you got another question, Dave? Or?
And one of our other students has chatted in the website cisecurity.org for that for the group.
Okay, great.
So we're in good shape. Thank you. And I think let me just check the queue. I think yes, we've got one more in the queue.
Yeah.
Can you give an example with Windows platform instead of Unix change mod?
Well, I mean, this example isn't really about a difference between Windows and Linux or Unix. Really, it's highlighting the fact that you shouldn't just follow what it says in a document and apply it as a solution.
Right.
So in this particular example, I mean, without going and dragging the file from my shelf to see if I can find one, that's a bit difficult in the context of this this webinar. It's really pointing out that the chmod command, chmod means change permission on, and we've got 755, so change the permission to 755 to all of the files, hence the star on the end, in the Oracle home bin directory. And really the point I'm making is that that would actually weaken the security because some files in that directory have already got stronger permissions. You know, the equivalent Windows command on a Windows platform that has got file permissions. I don't know what the Windows command is for chmod. I don't normally work on Windows platforms, right? I normally work on Unix platforms, but I hope you understand, the questioner understands that this is really about the issue of not just blindly following a list. It's not really about the difference between Linux and Windows.
Very good. Thank you.
Thank
you, Pete.
Somebody's written that there, yeah.
yeah, that I did. Yeah, and I think that's it for now. Thank you very much, Pete.
Excellent. I'll carry on. So just taking an example of the CIS benchmark, I just wanted really to highlight that these lists don't include anything about your personal data or your specific data for your organization. So maybe the data you're particularly interested in your organization is credit card details, or maybe it's HIV status, or it's, in this particular example on the slide, it's personally identifiable information, PII, that's what that stands for. And this one I've picked for two reasons: because it's actually in the file, in the document, but also I don't believe the answer is the right answer anyway. It's not a general enough answer that would suit everybody. So imagine I've got a database and I've got some personally identifiable information in my database. I'm in the UK, so by law I'm obliged to conform to the Data Protection Act. I'm not supposed to let your data be given out to other people. You know, what we're getting here in the document is the solution is encryption. So it's saying when a table contains a large number of columns of PII, so we've got lots of data, lots of different types of data, it can be beneficial to encrypt an entire table space instead of columns. That, in my particular case, generally we're not required to encrypt personally identifiable information anyway to conform with the Data Protection Act. So that's, again, really an example that these documents don't talk about your data, and they also, perhaps when they do, and this is very rare, the answer is it's very general, and it's not really specific to each person's circumstances. So, second excitingly high, there isn't anything in the score document that relates to your data. So it's really just highlighting the fact that you must consider the data first, and relying on checklists is still a valid thing to do, but it's not going to secure. It's really this. The right method to secure the database. We finally get there. We must start with the data. We have to think about the data. What is the key data in your organization? You know, it might be credit card data, it might be HIV data, it could be anything, it could be bank details. We have to understand what that data is and identify it. We have to understand the data flow and the access to it. So where is that data? Which tables is it in? How does it get into the database? Which types of users type it in screens? Which feed processes bring that data in? Which processes take data out of the database? Which types of users read it? Which backup processes read it? And so on. And then we have to think about the access to it. Who can access it? So for all those different types of access paths, who can access the data? So the whole thing really is about understanding the problem of securing your data. So you have to identify your data and understand who can access it. Hardening is still important, hence it's in red in the middle. It should be part of the solution, so we should apply general hardening to secure the database, but it should not be the solution. We have to start with the data first. Checklists don't mention your data to emphasize that point from the last few slides. So, to emphasize a second point, which we discussed briefly when we talked about two examples of solutions, and the time-based and the clever-based thing, is that overarching solutions are needed with databases. Databases are just too big, too complex. They are generic software. You know, you decide what application you're going to put in it. You create tables and indexes and views and procedures and everything. You know, Oracle is designed as a very flexible piece of software. So you design the structure, you put your data in it. Often people don't think about the security. This is a big problem because there is such a complex relationship between the data, the privileges, the parameters, the people who can access it, the programs, and so on. We really can't think about revoking hundreds of individual privileges or setting hundreds of different parameters. It's just not a practical solution with an Oracle database. This is why we must understand where the data is, understand all the different access paths to the data, understand if the data has been copied within the database itself or copied outside the database, understand how the data moves in transit. Is it being accessed through database links from another database? Is it being copied to tape? Is it being sent off through a feed program to another database? Is it being replicated in a test database? We have to understand where the data is, and then the problem becomes much smaller because we can think about putting solutions around the data itself rather than thinking about hardening thousands and thousands of possible combinations of parameters. So this flexible approach, really, we need to concentrate on the data first. So this diagram really is just about highlighting understanding the architecture. So we start off, we have to think about the data. So in my particular example, I might decide that my credit card data is my key data. My credit card data is stored in a table called credit card. It's in a schema called Orablog. It's in the database. We have to then just think, and this doesn't take more than 5-10 minutes to do this. Think about, within your own organization, who can access that data, which users can access it, which groups of users. Is there any power users that access it, people using Excel or Crystal Reports or business objects? Are there any backups that take copies of that data? Are there any feeds that bring that data in or take that data out? Is the data being copied to test or development databases? You know, if you secure, you do a lot of work securing your production database, but then every day you copy the data to a test system, but you haven't done any security whatsoever on your test system, you've wasted your time and your money. Because somebody who wants to steal it will know this, and they will simply avoid all of your security, all of your auditing, and just simply steal it from the test system. So we have to understand where the data is.